So for topic 6, lesson 2, the assignment, as you'll notice, is posted in Schoology in that folder, and it's due on Monday at 8 o'clock. It's 2 days after your teacher assigns it. So if your teacher assigns it on a different day, it's due 2 days after that. So we're going to start on page 119, and we will use Desmos.com, so have your Chromebook ready. So the first activity that you see in your book, we would do it in class to see what's happening, but we're going to skip it for now. If you have the opportunity to do it, it really is kind of cool how things work out. So we're going to go to the next thing that I want you to do. We're going to graph this equation, f of x is equal 2 to the x. And we want to see what it looks like. And we'll eventually use Desmos, but right now I want us to plot and see how it works. If you don't have graph paper at home, just watch along with me. So I have a grid paper here, and we're going to use the equation f of x, that's our function, is equal to 2 to the x power. Let's just first look at when we plug in values, what's going to happen with this. So this is going to be 2 to the negative 2. What does that give me? Well, think about it. That's going to flip it over, so that's 2 squared, so that's going to be 1/4. Then we have 2 to the negative 1. Again, it flips it over, so it becomes 1/2. 2 to the 0 we know is 1. Whoops, 1. 2 to the first power is 2. 2 to the second power is 4. So now we're going to graph that. So I'm just going to draw my grid in. And if you had graph paper at home, you could just do this same thing. Okay, now we're going to plot our points. So we have negative 2 and 1/4. So this is 1. So look at what we have to do. We have a 1/4 and we have a 1/2. So I'm going to actually plot negative 1 and 1/2 first. And then 1/4 is going to be about right there. Then 0 is 1. That's one of our points. 1 and 2. And then 2 and 4. 1, 2. I was going to say something that's right there. That should be. So 1 is 2. And then 2 is 4. Okay, so our graph. Now our graph with this part right here is just going to keep on going up like this. This is the part that's unique, and that's one of the things we're learning about. This graph will get closer and closer and closer, but look, let's plug in some other numbers and see what happens. So let's say that I have 2 to the negative, let's go to a negative, as it gets smaller, let's go negative 10. So that's going to be 2 to the negative 10. That's going to be 1 over 2 to the 10th, which is going to be 1 over 2 to the 10th. I don't know that off the top of my head. But if I take 2 to the 10th power, that gives me 1 over 1,024. That is really tiny. And it just keeps getting tinier and tinier and tinier. That's all the way out here at 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here, you can barely tell that it's off the line. And that's what will happen. So what we're looking at is, can it ever be 0? Can f of x ever be, if this is my function, ever be equal to 0? Well, this just keeps getting smaller and smaller and smaller, but it never hits 0. And that's the thing that makes exponential functions so cool, is it will get closer and closer to that x-axis, but it will never touch it. Okay? So actually it's not, is that going to be equal to 0? I wrote that wrong. Is x ever going to be equal? No, it is right. If f of x is equal to 0. Okay. So that's what we're looking at. And so on this next page, we're going to talk about what the characteristics of this are. So we're going to look at the domain. And we're going to look at the range. Okay, domain, remember, is those are your x values. What can your x values be? Well, is there any restriction on what my x values can be? No. So your domain is going to be all real numbers. But look at my range. I can't go past this line. I'll get closer and closer to it, but I will never touch it. So my range is going to be from here on up. It's going to be y is greater than 0. It will never touch. Okay, it will never come down to right here. Okay, so we'll never hit that, so my range is like that. And that actually has a certain name. This line right here, and I'm going to go to the next slide so you can see it. Okay, so we've already talked about it is continuous. Okay, it is continuous in all the y values, so our domain is all real numbers. Make sure you write that down. The function gets closer and closer to the x-axis, but it will never reach it. When a function approaches a line in this manner, that line is called an asymptote. So an asymptote is where your graph gets closer and closer, but it will never cross it. Your asymptote here is the equation y equals 0. That is your equation for your x-axis, because notice it crosses at 0. So it's actually crossing the y-axis, and where does it cross the y-axis? It crosses at 0. So that's y. So that's your asymptote. That determines your range. Your asymptote is going to determine your range, so pay attention to that. So in your notes, if you haven't already written it down, you want to talk about your domain is all real numbers, what your asymptote is, okay? And you might need to someplace write that down or just know it. It's a function approaches a line. That line is called. So the function approaches a line, and that line is called the asymptote. Okay? So get that in your notes. Pause if you need to. Okay, so now it says identify the key features of the function f of x to the b to the x. And that's the way we're going to write exponential functions. It's going to be f of x is equal to b to the x. And we'll add more to that later on in this lesson. So we're going to find these two functions. We're going to find when b is 2, so f of x is equal to 2 to the x, because b is 2. And then we're going to also find it for f of x is equal to 1/2 to the x power. But we're going to do this on Desmos. So let's go out to Desmos right now. And here we're going to put in that function. So we're going to put in, and you can put in f of x. I'm just going to put y. So I'm going to come down here and I'm going to go y equals, and notice these buttons down here at the bottom. So that's going to be 2 to the a to the b, and that's going to be x. And notice your graph comes in. That's what we just graphed. Isn't that pretty slick? Okay, so look at that. And we've already talked about our domain is going to be all real numbers. Our range is going to go from the y-axis, the x-axis up, and that's going to be my asymptote. Okay, let's graph the other one. So now this is going to be y equals 1 divided by 2. And then I'm going to have to move that out here to the side, and then I go b, and it's going to be to the x power. Let's see if that will actually graph it. Oh, it did, yes. See the blue one. Now notice it's coming down. It looks like the red one's going up, the blue one's coming down. Okay? So look at that. We're going to look at the domain and the range. What's my domain? What are my x values? Any restrictions? No. What about my range? Well, again, my range is limited by the x-axis because it will get closer and closer, but it will never cross it. So therefore, my asymptote is actually the same. Let's go back to my note. So if I were to sketch this one, if I'm sketching this, this one looks like this, okay, and gets closer and closer. Whereas if I'm sketching this one, it comes down, and it gets closer and closer, but it never touches. Okay, so those are just sketches of them. So my asymptote in both of them is going to be y equals 0. Y equals 0. What's my domain? Well, are there any restrictions on the x? Nope. So this is all real numbers. And all real numbers. Okay? What about my range? Well, notice my range is restricted. It goes from here up. It goes from here up. So my range is going to be y is greater than 0. It doesn't even hit 0, and that's important you understand that it's going to be y is greater than 0. It does not touch it, so y is greater than 0. Now, on this one, as my x increases, my y increases. So this is an increasing. So whoops, I can't just circle it. So f of x is equal to 2 to the x. This is increasing. Whereas you can see here, as x gets bigger, okay, as x gets bigger, my y gets smaller. So this is going to be decreasing. And this is always going to be true. If I have a whole number for my function, it's going to be an increasing. If I have a fraction, and the way we write a fraction is we say that that is between, that b is between 0, and 1. This means fraction. That's going to be decreasing. Okay, this one's increasing is what that's supposed to say. I can't even read my own handwriting. Increasing. This one is increasing. This one is decreasing. Couple pages in your book and where it says, do you know how? That's where this problem is, and it actually has a graph in your book. This is in your book. So go a couple pages over, and we're going to graph this. This says drag the points. We're not going to drag points. We're going to make a table because I think we learn better, and we're going to go -2, -1, 0, 1, and 2. We're going to see what's happening. And this is 3 to the x power. So we're going to plug in 3 to the -2, 3 to the -1, 3 to the 0, 3 to the first, 3 to the second. Well, 3 to the -2 is 1 over 3 squared, so that's 1/9. 3 to the -1 is 1 over 3. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. Now we're going to plot those points. So let's make an axis first. So I'm going to make this as my axis. And this is my axis. So just draw an axis in. Nice straight lines like mine. Okay. So now we have a -2 and we have a 1/9. That's going to be down there low. -1 and 1/3, a little bit bigger. 0 and 1. 1 and 3. And 2 and 9. Okay, so this is what my graph looks like. I want you to notice a couple things here. We're going to talk about the characteristics. So let's look at domain. Domain is still all real numbers. Range. Well, let's look at the asymptote. Okay, the asymptote, notice, is blocked down here. It can't ever go past that. There's no way that I'm ever going to get this to be equal to 0. So 3 to the x power can never be equal to 0. There's not going to be a way we can do it. It will get closer and closer, but it will never cross it. So that is our asymptote. Y is equal to 0. And that's going to be the asymptote on most of them that you're going to be doing this year. Now, your asymptote determines your range. So your range is y is greater than 0, not equal to, just greater than. The other thing I want you to notice is, see how it's 3 to the x? And notice both on 2 to the x and 1/2, they all have this point. Exponential functions, unless there's a plus or a minus, which you won't see, go through this point of 0, 1. The other thing I want you to notice is 3 to the first, so when x is 1, it's going to be whatever b is equal to. So when x is 1, b is going to be your y value, and x squared is going to be a 9. And we're going to have some problems later on in this lesson that will be about finding out different characteristics and looking at that. Good. Now we're going to do the same thing with this one, and I realized that we could just graph this on Desmos. And when we get yucky ones, we might. But I want us to go through the motions of what's actually happening with this so we can see. I usually always choose -2, -1, 0, 1, and 2. 5 points will usually give me enough to see what's happening. So this is 1/4 to the -2. That means that's going to be 1 over, sorry, that's wrong. That means it's going to flip that fraction. Okay, so it becomes 4 over 1 squared. That's 16. Ooh, we're going to have to adjust our graph because of that. Then we have 1/4 to the -1. That's going to be 4. And then, of course, 1/4 to the 0 is 1. 1/4 to the first is 1/4. And 1/4 to the second is 1/16. So really tiny. Okay, so I'm going to draw my axis in a different location. I'm going to pull it all the way down here and see if I can make it work. So we're going to pull our axis down a little further. And because it is a fraction, you can probably tell what's going to happen with it. But let's plot our points to make sure. So we have -2 and 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ah! Almost made it. So we're going to just put a point out there. -1 and 4. Look how quickly this drops. Okay, and then here it is again. 0 and 1 is always going to be a point. Okay, and then we have 1 and 1/4. And then we have 1 and 1/16, barely even above the line. If you were to connect all that, this graph, and notice, okay, It's going to be decreasing. Okay, this is a decreasing. Because I have a fraction, because b is between 0 and 1, I'm going to have a decreasing function, decreasing graph. Let's look at the domain. The domain here, that's supposed to be a d. So the domain is going to be all reals. We can plug anything we want to in for x. It's our range that's going to be restricted. Look at your asymptote. Your asymptote is going to be right down here. It's just going to be y is equal to 0. That determines that my range is going to be y is greater than 0. Okay? This is a decreasing function. And look at some of those points. Look, like I said again. When x is 1, that's going to be your b value. That's your b value. Okay? But look how quickly it changes. And exponential functions, that's one of the things about it. They change very quickly. This problem is not in your book, and I know that. So just want to point that out. This one is not in your book, but the second part of this is in your book. So this one's not in your book. So a network administrator uses a function f of x is equal to 5 to the x to model the number of computers a virus spreads to after x hours. If there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network? So notice this picture. At 1 hour, one computer has spread to 5 computers. After 2 hours, it's spread to, oh my gosh, look at those. So 5, well, we can do. So let's go. Let's make a table. Let's see what happens. If it is, now, am I going to have a negative? No. I'm going to start at 0. I'm going to go to 1, 2, 3. So this is 5 to the 0, which is 1. 5 to the first, which is 5. Okay, after 2 hours, it's already spread to 25 computers. After 3 hours, it's 125 computers. Okay, that's quick. And this should sound familiar. You'll remember that COVID was said to be an exponential function because it does spread. If one person has a virus, they infect everybody around them, which then exponentially makes that number go up as far as who has COVID. So then we would graph this. I'm just going to sketch it for now. Actually, we're going to go out to Desmos, and we're going to graph this. Okay, so hold on. Let's go to Desmos. So I'm going to do the function y equals 5 to the x power. Look how quickly that goes up. Now I'm going to shrink it so we can see what is happening. Look at how quickly that's going up. Now the other thing I want to show you that Desmos does is, let's say I want to know what is the point at right here. Okay, do you see when I touch it? It gives me that point. And there's a way to put points on. So at 3.67, okay. At when x is 3.63, y is 345. See how it keeps on going? So we can just trace that up there. Okay, so keep that in mind. We're going to leave that graph there. Go back to the notes. Okay, graph the function. We did that. So now what we want to know is, if there are 1,000 computers on the network, about how many hours will it take for the virus to spread? So we're going to go to 1,000. When x is 1,000, go back out to Desmos. Okay, keep going. Here we go. When it is that, look at what we have. Up. Keep on going up, going up, going up. Okay, so 1,000 computers. We can't get it exactly, but it says like 4.3. We're going to use 4.3. Do you see how I did that? It came up here, and I know there's a way to plot points, but I'm not finding it. So when y is 1,000, I get 4.3 hours, so about 4.3. Okay, see how I did that? I'm just touching the graph, and I'm finding out at 1,000 hours. So when y is 1,000, I get about 4.3. Can't hit exactly, okay? But 4.3 is what we're going to be using. So go back, and we're going to use that for 1,000, that it's going to be 4.3. About how many hours will it take for the virus to spread? About 4.3 hours, okay, is what our answer is that we use that, our graph, to approximate. Now what we can do is we can check that. We can take f of 4.3, we plug that in, 5 to the 4.3 power. Take your calculator, 5 10th 4.3, and it gives us 1012. So maybe we could do 4.2. Let's take 5 to the 4.2, and that gives us too little. So you can see that it's going to be really close, and we're just going to use that 4.3. Okay? The question that's in your book is, it then says, what about for 50,000 computers? So we're going to go out and we're going to look at 50,000 computers. Go out to Desmos. Oh my gosh. Just keep on scrolling in until we get to 50,000. So here we go. I'm going to, oh, I can pull the point. Can I pull the point? So at 50,000, I can't get the point to go up there. See if we'll go to 50,000. It's not wanting to cooperate with me. So anyway, we would find at 50,000 computers, when x is 50,000, how many hours would it take? Be equal to it. So we need to find it for that. Hold on a second. Well, I couldn't figure it out on Desmos, so maybe you can play with that and figure that out, but I'm going to move on for now. If you're in class, I will have figured it out by then. Okay, for habits of mind in your book, it says, suppose the spread of another virus is modeled by that same thing. If it takes the virus 5.5 hours to spread, okay, what tools could you use to investigate this? Well, we already using Desmos, but also just use a calculator and take 5 to the 5.5 hours and find out what that is equal to. So a graphing calculator, okay? Or you can just use a regular calculator. It doesn't even have to be a graphing. We can use Desmos in order to do that. So I want to show you the form for an exponential function. Then we're just going to stop right here. Then we'll pick up the rest of it tomorrow. An exponential function is the product of an initial value, okay? An initial value. That's going to be a. That's your initial value. And a constant ratio. This is important. It's a ratio, and we're going to talk more about that in the next half of this lesson. The ratio. That's important. So a is the initial amount. B is the constant ratio. And a is a non-zero number, because if you make this 0, well, 0 times anything is just 0. And b has to be greater than 0, and it can't be 1, because if I just put a 1 in here, well, 1 to anything is just going to give you 1. Okay, so I just want to stop right there. We're going to pick up right from there next time. You can start on your homework from 6.2, and then I'll do the next video, and I'll put that out later. Thank you very much. If you have questions, you know where to find us. We'll continue this later.